Good evening, everyone. Thank you all for being here today. And we are a group deployment team, and our topic is containerization versus virtual machines. In a simple word, this topic is about how we package and run software in the cloud, which is how most modern apps work today. So, my name is Mohamud. I'm presenting the first part of our topic, and I will introduce the basic concepts and the architecture. After that, my colleagues Abdulkadir and Ugbad will continue with the next sections. So let's begin. So the deployment dilemma. When building a system is in the cloud, engineers always um, face one big question. We call it the deployment dilemma. So the dilemma is basically choosing between security and efficiencies like speed, performance, resources, and cost. So on the left, we have virtual machines. They are the traditional method, and virtual machines focus on strong isolation and security, but they are slower and use more resources. So on the right, and we have containers. This is the modern method. So containers focus on speed, efficiency, and lightweight deployment. So they start faster and use fewer resources, but the security isolation is a bit weaker. So today we will explain these two technologies step by step so you can clearly understand why a company might choose one over the other. So the concept of a virtual machine. So to understand virtual machines easily, let's use a house example. Okay. So imagine living in a detached house and you have your own foundation, you have your own foundation, your own water pipes, your own electricity system, your own walls. Everything is separated from your neighbors, right? So the benefit is you fully isolated. If your neighbor's house has a problem like a wire and like an electrical issue or a wire, like it won't affect your house. You are safe. But the downside is it's expensive and wasteful. So each house needs its own foundation and utilities, even if it's only one family living there. So in technology terms, this means every virtual machine has its own full operating system. So this uses a lot of CPU, this uses a lot of memory, storage, even if the app inside is not big. So I hope you get that one. So concept is the container. Now let's compare and that to containers. So containers are like apartments in a big building. Each person has their own and room and privacy, but everyone shares the same main building and structure: the foundation, the water pipes, the electricity, the security, the walls, and like the benefits in here is containers are very efficient. So and we can host many containers inside one server, just like many apartments in one building. But there is also downside. So privacy is lower. If someone in the building makes noise, maybe he loud or she loud the music, you might hear it. So in technology terms, this means containers share the host operating system kernel, so they don't each have their own full operating system. So this is why and containers are faster and lighter, but slightly less isolated than virtual machines. So let's move on this one. So virtual machine architecture. Now let's look at how a virtual machine is built on the inside. At the bottom, we have the physical hardware, the real servers, as you see here. On the top of that, we have the hypervisor. The hypervisor's job is to divide the server into many separate virtual computers. Tools like virtual machineware, Hyper-V, and VirtualBox all work as hypervisors. Above of that, we have very important and each like here is I think yeah we have something called the ghost and operating system. This is very important. So each virtual machine is a full copy of complete operating system like Windows or Linux. So that means if you want to run 10 applications using virtual machines, you need 10 separate operating systems. This takes a lot of RAM, CPU, and storage. This is one reason why virtual machines are heavier and slower to start. So let's move on and this slide, container architecture. So I hope you notice here the big difference. There is no hypervisor, there is no guest operating system for each app. So instead of that, we have a container engine such as Docker, but containers still need to stay separated to do this. Linux uses special features, as you see, namespaces, groups, all of these stuff is. So this design makes containers simple, efficient, and very popular in cloud and environment. So now that we have understand what virtual machines and containers are, I will pass it over to Abdulkadir and he will explain the performance comparison and the real world impact of these technologies. So welcome, Mr.
Thank you very much, Mr. Mohamud. Hello everyone, I'm Abdulkadir. Now Mohamud has explained the concept. I'm going to show you the real world impact of these differences. Please look at this comparison stock. On the left, for the virtual machine, you see the big red block labeled guest OC. The red block represents wasted resources. If you want to run 10 applications in VMS, you need to run 10 operating systems. This is a lot of wasted CPU and RAM. On the right, for the container, the red block is gone. Now we don't have the red block anymore, right? We have cut out the middleman. The application sits almost directly on the hardware. This makes it incredibly efficient. Let's move into the next slide. Performance analysis, startup. Emphasize the speed difference. And let's say here, this efficiency gives us a massive advantage in speed. So performance analysis gives us a massive advantage in speed. Imagine it's a Black Friday and your shopping website suddenly gets 1 million visitors. You need to add more servers instantly, right? If you use VMS, you have to wait for the computer to boot up, load the BIOS, and load the driver, and also load the start or the OC. And this takes 30 to 45 seconds. In the tech world, that's a lifetime, right? If you use containers, you are just starting a process. It takes less than 1 second. And this allows companies like Netflix or Uber to scale up and down instantly. Let's go into the next slide. We have resource density here. It's not just about speed, it's also about money. We call this resource density. On the left, you see the VM box. It's loosely packed because the gas OC is so heavy. You can only fit a few VMs on one server. On the right, look at the container box. It's tightly packed. Because containers are just small files, we can't fit 2 to 3 times. We can't fit 2 to 3 times more applications on the exact same server. For a company paying for cloud servers, using containers can cut the infrastructure bill in half. Let's go into our next slide, the security trade-off. However, in engineering, there is no such thing as free lunch. We gain speed, but we pay price. Security, remember the apartment analogy. The VM has a very small attack surface. The hypervisor is a very small, but it's a very simple hard wall to break through. Container has a large attack surface. Because all containers share the Linux kernel, they rely on the kernel to keep them safe. But the Linux kernel is massive and complex. It has millions of lines of code, which means it might have bugs. Let's go into our next slide, the shared kernel risk. Explain the kernel breakout. Here, we will explain the kernel breakout, right? Let me explain the nightmare scenario. We call this a kernel panic or container breakout. Look at the diagram. Imagine container 1 is controlled by a hacker, because container 1 shares the kernel with the host. If the hacker finds a bug in the kernel, like the famous tactical vulnerability, they can't break out of the container. Once they are out, they have root access to the entire server. They can see container 2 and container 3 and steal all the data. In a VM, this is much harder to do because of the hardware isolation. This is it for me. Now I will end up my slides in here, and our colleague Ugbad will continue our next slides. See you.
Hi, I'm Ugbad. So Abdulkadir explained the scalar party, the security risk. Does that mean we should use the container? No, it just means we need to be smarter about how we secure them. Here are the 3 ways to fix this problem. Number 1, rootless container. Usually containers run at the admins. We stop that. We run them standards users. So if the hackers break out, they still don't have the power. Can be these standards for security combating. This acts like a filter. It blocks a dangerous system called the app doesn't need an image scanner. We use tools to scan our codes for virtual and bugs before we even turn into the container on. So the next slide is orchestration at scale. Well, in the real company, you don't just have one container. You have thousands. Managing them by hand is impossible. So we need to use tools called Kubernetes. Things like a Kubernetes as a traffic controls or an orchest contact is automatically handled. Deployment, putting the containers on a service, scaling, adding more container when traffic is high. Self-healing is a container crash, a Kubernetes notice and restart it immediately. Well, without a Kubernetes, modern containers would be possible. So the next slide is the future macro VMS. The technology moved fast. The industry realized we wanted to speed on containers and the security of VMS. So companies like Amazon create something new. A micro VMS is a virtual machine that has been stripped of everything unnecessary. It doesn't have a full heavy OS. It boots up in 125 milliseconds like a container, but it uses a hard isolate like a VMS. This feature is best both of the wallet. So the next slide is a decision matrix. So if you are in architect, how do you choose? And here's are the simple guides. Choose a VMS if you need a strict isolate. For example, if you are a bank or handling healthy records, the law often requires you to use a VMS. Also, if you need to run a legacy software, VMS are the best. Choose containers if you want it to speed and density. If you are building a modern web or app, microserver or stand-up, containers are the standard choice. For the conclusion, to conclusion our presentation, Containers have won the battle for modern development. They are standards for web apps. Security VMs are still the king of security. They are not dead. They are just they are different now, and hybrid best architectures often use both. We often run containers inside of virtual machine to get safety and speed. Uh, and here are the for the last slide for the next slide are the academic papers and the articles we use it to search the topic, including the EA and IEE combinations of performance. So that's all. Thank you so much.